Lately, life has become a box. We are living in a four-wall world, and people are used to this orthogonal routine life. What if this is not what everyone wants, but what is designed for them? What if by changing the city's design, we could change their perspective, emotions, and way of living? Textile Reinforced Concrete will give the cities the innovation and infrastructure they deserve. Let's head to a deconstructivist world, where buildings are no longer dreams in kitchen boxes. Let's forget about the rules and break the regular shapes we're all used to. TRC allows architects to free their minds and create new designs that revolutionize a space. Using this technology, they can create a controlled chaos that completely transforms the user's experience. Undulations, bifurcations, faults, non-rectilinear geometry, the sky is the limit. This new phase of architecture will let people experience a bigger, wider, and better related space, allowing them to finally live outside the box. As Bernard Schumi once said, the ultimate pleasure of architecture lies in the most forbidden parts of architectural act, where limits are perverted and prohibitions are transgressed. The economic and environmental benefits textile reinforcement concrete contribute are worth to mention. With a growth estimation of 2.5 billion people by 2020, the building's floor area will increase. This means buildings will have a crucial effect on future CO2 emissions. Approximately 3.75 million buildings are constructed annually worldwide, representing over 10 billion tons of concrete produced each year. During the production of 1 ton of cement, 1 ton of CO2 is released into the atmosphere. In 2019, we produced 4,100 million metric tons of CO2 only with construction. The cement industry is responsible for 7 to 8 of the global CO2 emissions and increasing, which makes this an alarming matter. The UN announced that these emissions need to fall about 16% in the next 10 years, causing governments to apply taxes to this building material. Around 90% of a building's structural materials and embodied carbon amounts come from floor slabs, and thin shell systems offers an alternative to these elements. This system reduces embodied carbon from 58 to 53% of the original amount, and can reduce the required concrete by up to 85%. This means that even if only 10% of the buildings use this system, 165 million metric tons of CO2 less than the current amount will be released each year.
Do you ever wonder about ways to make the world a better and more sustainable place? We do, and we believe that textile reinforced concrete could bring that place to us. We believe that this is a promising field, and as such, we propose an ACI competition that promotes innovation of TRC in shell elements. Why is this technology important? TRC provides ductile, strong elements that still possess the flexible behavior of textile fibers. This will allow architects and engineers to design smaller, lighter elements, capable of generating large and comfortable spaces for the final client. Also, TRC would help with several of the UN development goals, such as encouraging inclusive and sustainable industry. It would contribute to the efficient use of resources and strengthen dynamic and competitive economies. Finally, it would promote the design and construction of sustainable infrastructures, improving people's quality of life. How would this competition work? Competition will entail the design of a unidirectional curved carbon fiber reinforced concrete slab. Participants will produce a concrete mix design and a resultant texture reinforced element. Materials to be used will follow specific ASTM standards. TRC will be provided by the ACI, which includes sheets of material, separation elements, and support for the casting process. Configuration of the reinforcement will be left to the discretion of each team, according to their slab design. For the casting of the element, each team must create a customized formwork according to their planning. Shipment of a concrete sample cylinder is required as well. Teams will be able to base their design on these diagrams. Possible addition of tensioning elements such as steel cables and the bases of the columns must be removable. These specifications establish general limit within which each team has freedom of design. What would be the requirements to participate in the competition? Each team will design, build, and present a slab that satisfies the architectural concrete requirements and the flatness and tolerance criteria. The element will be submitted to evaluation by a committee. How will the committee evaluate submitted elements? A uniformly distributed load will be applied throughout the area of the slab element. The load will be increased in 50 kilograms distributed over the structure in intervals of approximately 1 minute. Maximum load is determined when the structure is not able to bear an additional load and therefore collapses. The contest will evaluate the impact of designs. Environmental impact of design. Cost to embodied carbon ratio. Usually, designs are quantified according to their cost, but if concrete is one of the highest causes of contamination in the world, perhaps its emissions should constrain these designs. Building industry is reinventing itself, and this parameter is a preparation for the designers of tomorrow, who will have to face a carbon emission cost efficiency challenge. In the same branch, the use of sustainable materials is encouraged, and these will reflect a lower cost than the calculated price at evaluation. Secondly, economic impact. Load to cost ratio. Participants will be evaluated based on the load size of their design according to their projected costs. This means that the contest will yield novel designs for TRC elements, aiding with the current lack of experimental knowledge about the use of this material. Not only that, but the project will also bring the use of TRC to the spotlight, which will trigger new investigative efforts in the scientific and construction communities. Consequently, this will lead TRC being more commonly used, turning into a scale economy, making it more affordable. Finally, the social impact. The participants will be evaluated by the functionality of their structure as an interior slab and its applicability in architectural design. It will be the first time that architectural concepts are considered in an ACI contest. This would lead to the creation of multidisciplinary teams between engineers and architects that better reflect the reality of construction in a real-world setting, providing habitability and comfort in a comprehensive perspective of the true role of infrastructure in society. Textile reinforced concrete is the future. By proposing this contest, we do not only want to promote a new way of construction, we want to change people's lives.